All right, Math A, here we go. We got lesson 4-4, rotations, day one. Now, this is our last rigid motion. We have done translations, reflections, and now rotations. Rotations are going to be a rigid motion, so they're going to create congruent shapes, just like translations and reflections did. But this one, the way to make a rotation is you're going to spin the object around a central location. So a central point is going to be called the point of rotation. So we're going to spin the image around things. Remember when we did a translation, it was kind of like sliding an image up and down, left and right, or even diagonally. That was a translation. A reflection was like flipping the image over, making a mirror image. So what we're going to see here with the rotation is we're going to spin an image around. Now we can go two directions when we're spinning it. We can go clockwise, called clockwise because it goes the direction of a clock. So if you've ever never seen a clock before, this is clockwise. This is this way, righty-tighty right there. And then this way is counterclockwise. Counter means against. So we're going against the clock here. So going this way, or if you prefer, lefty-loosey. All right, so we've got clockwise, CW, counterclockwise, CC. So those are the two directions. There we go. All right, so we're going to start by labeling the quadrants on the coordinate plane. So in our coordinate plane, hopefully you've done this before in another class, this is the first quadrant. This one over here would be the second quadrant. This one, oh, we've done this in this class before. Yeah, we did this like 2 units ago. All right, fourth quadrant. So there we've got our quadrants. So each time that we do a rotation of 90 degrees, we're going to be moving one quadrant. So like if you decide to spin all the way around, I think most of you that have skateboarded or snowboarded or seen anybody doing this, you know that a 360, that's going all the way around, right? 360, that makes sense. So if I want to start here, and I want to go all the way around, that's 360 degrees. But if I only want to do it one quadrant at a time, that would actually be in 90-degree increments, because 90 would put me here. Another 90 would put me here. Then now I'm at 180. The next 90 would put me here. That's 270. And then back to here, 270 plus 90. That brings me back to 360. So I took 360 divided by 4. And that just means each time that I move a quadrant, I'm going to move 90 degrees. So I can move counterclockwise in this direction, or I can move 90 degrees in this direction and go clockwise. So if I'm in this quadrant and I want to go 90 degrees clockwise, that would put me in the fourth quadrant. If I'm in this quadrant and I want to go 90 degrees counterclockwise, that would put me in the second quadrant. All right, so we're going to plot A, which is at 2, 4. So A is at 2, 4 right here. Hey, A, how you doing? And then B is at 0, -4. So 0, -4, B would be right here. All right. So we've got those 2 points. We're just going to be rotating points today. So I want to rotate A 90 degrees counterclockwise about the origin and give the coordinates. Okay. So A is in this quadrant. I want to go counterclockwise, so I'm going to go in this direction. So if I go 90 degrees, I'm going to show up in this quadrant. But where in this quadrant? Now, when it says about the origin, it means this is my spinning point. I'm starting at this point, and this is what everything is going to spin around. So when I spin around this point, I have to keep the same distance every time I spin it. One thing that we can do to find out where our new spot is to literally spin our paper. So keep your eye on A. If we go 90 degrees in this direction, let's look where it would end up after a 90-degree spin. So we're going to spin around this point here. I'm spinning around that point. I've now moved, oh, my pens are getting in the way. I've now moved 90 degrees by spinning my paper 90 degrees. Here's A. A is now at the position -4, +2. Right? I'm pretending like this is the second quadrant now. So A has moved from this point here at 2, 4. Now I have spun it. It is now in this position at -4, +2. All right, -4, +2. All right, so A prime is now in the position at -4, +2. Sorry, there we go. So that would be here. All right, now I want to take A and rotate it 180 degrees counterclockwise. Now that's going to mean that I move 1, 2 quadrants to get there. All right, so keep your eye on A, and we're going to spin it 2 quadrants. Here's one spin, there's 90 degrees. Here's another spin, oh, don't get dizzy. There we go, there's the new spin. So here's where A is at now. A is now at -2, -4. So we are now at -2, -4 after 180 degrees, so 2 90-degree rotations. All right, so we were at -2, -4. That's right here. There's my new A. A prime prime is what we'll call it, just for funsies. So that would be A prime prime. It's now at -2, -4. All right, rotate A 270 degrees counterclockwise about the origin. Oh dear. All right, so that is 3 90-degree rotations. So there's 1. There's A in the second quadrant. There's 2. A's in the third quadrant. There's 3. A's in the fourth quadrant. So now we're at 4, -2 for A. So 4, -2 is the new location. I'm out of colors. So A prime 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 is now at 4, -2. It showed up right over here when I spun it. All right, rotate B 90 degrees clockwise about the origin. Okay, so here's B. B is between quadrants 2 and 3. It's not in any specific quadrant. So if I go 90 degrees clockwise, I would expect B to end up now not being between 2 and 3. It should end up being between 2 and 1. And I'm going clockwise this time. So let's go ahead and spin it clockwise. And here's B. B is indeed at 0, +4. All right, so we've spun it. And we saw that, I'll do this color. Oh, green. Here's my B prime after going 90 degrees clockwise this time. So B prime ends up being 0, 4. All right, what do you notice about 90 degrees and 270 degree rotations? Okay. So looking at this, the thing that I notice about a 90-degree rotation, this was 2, 4, this is 4, 2. The X's and the Y's have switched. That's 180, so that doesn't count. Okay, at 270, this is 2, 4, this is 4, -2. So I do notice that the X's and the Y's are switching position. Let's see if it works for B's. So B was 90 degrees clockwise, 0, -4, 0, 4. Oh, I put B in the wrong spot. Okay, we're just going to retcon this and pretend like some of you are probably watching that going, why is he plotting it in the wrong spot? I plotted it at -4, 0. Sorry about that. So anyways, let's pretend Use our imagination. Let's pretend that -4 is 0. How did I do that? I don't know. All right, -4 is 0. And here we see, yes, when we go at a 90-degree, the x's and the y's are kind of switching position. Now, some of the signs are changing, but in general, the x and the y switch positions when we move 90 degrees or 270 degrees. Now, when we went 180, they didn't switch positions, but all the signs changed there. So that's different. So we're going to see about that. So what we notice is the x and y coordinates. Oops. Are switching positions. Interesting. All right, here we go. So here we've got C's at -5, -2. Let's make sure I graph it correctly this time. So -5, -2, there's C. Not prime, it's C, just C. D's at 1, -4, so there's my D. E's at -6, 0. -6, 0, making sure that I'm graphing it in the right spot. All right, so rotate C 180 degrees counterclockwise about the origin. Okay, I can predict where this is going to end up being because of the pattern that we saw on the last one up here. But let's go ahead and spin it. So if I go 180 counterclockwise, that means this direction here. So I'm watching C. That is going to move 1 quadrant, 2 quadrants. It should end up over here in the first quadrant. Let's see if that happens. 90 degrees, 180 degrees. Yes, it does end up in that quadrant. It shows up at 5, 2. All right, new point is 5, 2. So it started at -5, -2. It's now at +5, 2. See what happened last time we did 180? Was it 2, 4? Now it's at -2, -4. See the pattern? Maybe? -5, -2, 5, 2. All right, 270 clockwise. So we're going to take D and go 270 clockwise. That means 1, 2, 3. We're going to be in the first quadrant over here after this. So D is over here. We're going to go clockwise this direction. So we're going to go 1, 2, 3. So we should be in this quadrant since we're doing 270 degrees. So 1, 2, 3. It's hard to keep it up on the screen. So that was D that we're moving. We should now be at 4, 1 in the first quadrant. Okay, so that's at 4, 1. We were at 1, -4. Now we're at 4, 1. Rotate E 90 degrees counterclockwise. So E is right here. We're going to go 90 degrees this direction. We're between the second and third quadrant. When we go over here, we should be between the third and the fourth quadrant. So 90 degrees that direction. And yes, we are right where we thought we would be. We are at 0, -6. We started off at -6, 0. Now we're at 0, -6. Hopefully you're starting to see some of the patterns that are arising here. Let's do C 270 degrees clockwise. Okay, here's C 270 degrees clockwise. 1, 2, 3. So we should move 3 quadrants because that's 3 90s. So 1, 2, 3, we should end up over here. So let's do that. 1, there's 90 degrees. 2, that's 180 degrees. 3, and yes, we are now 270 degrees. We're in that fourth quadrant just like we were predicted. This is at 2, -5. All right, so 2, -5. Make sure that I keep it up so you can see this. All right, rotate D 90 degrees clockwise. 90 degrees clockwise. That means I'm going to go No, counterclockwise. That means I'm going to go this direction. So since I'm in the fourth quadrant, I should end up in the first quadrant when I go 90 degrees counterclockwise. And that's exactly what happens. 90 degrees. I'm now at 4-1, just like I predicted. All right, so after that, we ended up at being at 4-1. Rotate 180 degrees clockwise. So we're going to take C, this one, and go 180 degrees clockwise. All right, so 180 degrees clockwise, that's going to be 1, 2. All right, so we should be in the first quadrant. Let's see if that happens. 1 and 2. Of course, that's where we are. We are at the point 5, 2. All right, so we're at 5, 2. All right, let's answer the final questions here. What do you notice about 180 degrees clockwise and 180 degrees counterclockwise? So with C, we started with 180 degrees counterclockwise and we ended by doing 180 degrees clockwise. Now let's see what happened. When we did 180 degrees clockwise, we got 5, 2. And when we go 180 degrees counterclockwise, we still got 5, 2. And it makes sense because if I start here and go counter or clockwise, 1, 2, I end up in this quadrant, the first quadrant. If I go the other direction, 1, 2, I still show up in the first quadrant. So no matter what, if we go 180 degrees, clockwise and counterclockwise does not matter. They're going to be the same point. They'll both be 5, 2. So for 180 degrees, clockwise and counterclockwise are the same. Now that's only if you're going about the origin, but we're just going to go about the origin. What do you notice about 90 degrees counterclockwise and 270 clockwise? So let's see if we did anything like that, and we did. We rotated D 270 clockwise, and we also rotated D 90 degrees counterclockwise. And look what happened. 4-1, 4-1. We got the same thing. So let's look at D. If I go 90 counterclockwise, that means I'm going to show up in the first quadrant. If I go 270 counterclockwise, 90, 180, 270, also in the first quadrant. So 90 degrees clockwise is the same thing as 270 degrees counterclockwise. You know what I meant. So anytime that we've got 90 degrees in one direction, it's the same as 270 in the other. If I took C and went 90 in this direction, all I would have to do is 1, 2, 3. I would have to go 90, 180, 270 in the other direction to get in the same spot. So 90 in one direction is the same thing as 270 in the other direction. So 90 degrees in one direction is the same as 270 in the other direction. All right, there we go. We have finished it. All right, so this should be like the last lesson before Thanksgiving. So happy Thanksgiving. I'll see you guys later. Bye-bye.